Hello everyone, welcome to MES e-learning channel. In this video, we will be discussing a numerical on unity feedback system. Here the question is where we have to find Kp, Kv and Ka and steady state error for the system with open loop transfer function. They have also given us a transfer function when input R of t is equal to 3 plus t plus 3t square, right. So, here let us start solving the numerical. Okay. So, the input, that is R of t is given as this, correct. So, this term indicates step, this indicates ramp, okay. And what about this? We will have to update this, okay. So, let us update the equation to this. So, we will add 2 in the numerator and we will add 2 in the denominator, t square remains the same. So, now what is this? This becomes parabolic input, okay. So, this is step, this is ramp and this is parabolic, okay. So, for step input, what is the magnitude? Magnitude is denoted by A, as we know. Let us write A1, okay. So, what is the magnitude? Magnitude is 3 for the step input, okay. So, for step input, positional error coefficient Kp will control the error, okay. So, what is positional error? It is given by Kp, correct. So, we know the formula for positional error, it is as follows. We also have g of s, h of s given to us. So, we will substitute the value and find out the value of Kp. Please make sure you are writing the question properly, because sometimes we write the question itself wrong and hence we get a wrong answer. So, write all the terms properly. Now, after substituting the value of g of s, h of s, we will substitute the value of s as 0 in this equation, and since s is here in the denominator, 0 multiplied here is going to give 0 in the numerator, and anything divided by 0 will give you infinity as the answer, which is undefined, right. So, Kp is equal to infinity, correct. So, we will have to calculate the steady state error, okay. So, steady state error for what? The step input. Steady state error ESS, let us denote it with 1, okay. So, it is given by the formula is A upon 1 plus Kp. We know the value of A, right, we know the value of A is 3. So, we will substitute 3 upon 1 plus Kp. We know the value of Kp, we found it out as infinity. So, infinity plus 1 will obviously give you infinity, and anything that is divided by infinity will give you answer as 0, okay. So, keep in mind anything divided by 0, okay, anything divided by 0 will give you infinity as answer, anything divided by infinity will give you 0 as answer, okay. So, we have found out the values of steady state error and we have found out the value of Kp in case of step input. Now, let us move ahead and find the values for ramp input. So, for ramp input, what is the magnitude? For that we will have to see the question. Let us see the question. So, what is the magnitude of ramp? It is 1, right. So, magnitude is 1 for ramp input. Okay. In case of ramp input, velocity error coefficient, that is Kv, will control the error. Okay. So, you will have to keep these things in mind. Okay. Will control the error. So, what is the formula? Kv is S tends to 0. So, we already know this formula, we will write it down. Okay. So, let us substitute the value of g of s, h of s in the equation. Okay. So, this s and this s will get cancelled out. Then we will substitute the value of s as 0 in this equation, and after doing that, what we will get? We will have 10 into 2 into 3 upon 1 into 4 into 5. After calculating, you will get the answer as 3. So, Kv is equal to 3. So, after finding the value of Kv, we will have to find out the steady state error, that is ESS2. Okay. So, what is the formula in case of ramp input? It is A, that is magnitude, upon Kv. So, magnitude in this case is what? It is 1. So, 1 upon Kv, that is 3, is the answer. So, 1 by 3 is the answer of steady state error in case of ramp input. Now, let us solve for parabolic input. Okay. So, what was the parabolic input? Parabolic input was correct. You can see in the question here, correct. So, what is the magnitude over here? Magnitude is 2, correct. So, this indicates the magnitude. So, magnitude is 2 in this case, right. So, here in case of parabolic input, acceleration error coefficient, that is Ka, will control the error. So, Ka, the formula of Ka is known to us. So, let us write it down and try to solve it. We will substitute the value of g of s, h of s in this equation, correct. So, what is the value of g of s, h of s? So, this s in this square will get cancelled off. So, now again when we substitute s as 0, we will multiply 0 with this whole equation. Anything multiplied with 0 is a 0. So, what we will get as answer? We will get 0 as answer. So, Ka is equal to 0. Now, let us move ahead and calculate the steady state error ESS. Okay. So, it is magnitude A upon Ka, A3 in this case. So, A3, the magnitude is 2. So, 2 upon 0, okay. Anything divided by 0, that is 2 divided by 0 is going to give us what? It will give us infinity. So, ESS3 is infinity. Okay. Now, we have to calculate what? The total steady state error. So, total steady state error, that is ESS, is an addition of all these 3 errors: ESS1, ESS2, ESS3. Okay. So, let us add all the values. ESS1 was 0, ESS2 was 1 by 3 and ESS3 is infinity. When we add anything with infinity, it is going to give us what? Infinity. So, ESS is equal to infinity. The total steady state error is equal to infinity. I hope you have understood. If you have any doubt, please write it down in the comment section below. Thank you for